All right, guys, so this is the second half of the 1-3 video. In this part, all we're going to do is we're going to learn how to put stuff into our calculator and get out the answers we want. Okay, so because you're honors students, this might seem odd, we are not going to find the line of fit. Okay, so we're not going to do all this. This involves plotting a bunch of points, and I'm sure you guys can plot and doing other stuff and then doing all this by hand. We're just going to put it in our calculator. Okay, so we're going to find the line of best fit. Okay, so the absolute best linear equation possible for this data. All right, so like I said, this all has to do with the calculator. So if you don't have your calculator now, I want you to pause this video, run and grab it, and then hit the play button when you have your calculator. All right, so hopefully you have your calculator now. And what I want to do is I want to go back to here. This is your X value, so we're going to plug all of these into the L1 column. Okay, this is your Y value, so we're going to plug all of these into your L2 column. Okay, so if I bring this back up, let's get out of here. So you're probably at the front mode here. Okay, so you'll go to Stats right here, and then you want to Edit. And it'll bring up all these lists. L1, list 2, list 2, list 3, list 4. We want the X value in list 1, the Y value in list 2. Okay, if you're looking at this and you don't have an L1 or an L2 or whatever, all you have to do is hit the Stat button and then go down to the Setup Editor, hit Enter, and that basically just clears it. Okay, so what I want to do in the L1, I'm going to put all these X values in. So 40 down. 45 down, 32 down, and so on and so forth. Okay, all of those. And then my L2s, I'm going to put the Y values from over here in, and so it's 170, 183, and so on. So I'm going to go ahead and pause this. I want you to pause it as well, and I want you to finish filling up your L1 and your L2 with all these numbers. All right, so after you put all these in, if you want to see like a scatter plot of it, go up here to this zoom button, and we want to go to zoom stat, okay, because that's where we put all these in is the stats. So zoom stat, enter, and here's a scatter plot of all this data. It reduces the window or enlarges it, whatever you need, and it puts all these data points in there, okay? So now we want to find the line of best fit. So we're going to go back to this stat, but now we're going to calculate, okay? And we're going to calculate the equation of a line because we want the line of best fit. So we're going to go down here to linear regression, enter, 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 and there it is, okay? So y equals ax plus b, here's our a, and here's our b. So I could write this linear equation as y equals 2.6x. So over here, y equals 2.6x. And then if I go back to the calculator, it'd be plus 64.99. Okay, this would be the line of best fit. Okay. Now, let's go back to our calculator. All right, so we have calculate linear regression. We are right here. Okay, now some of you will have an R down here. Some of you will not have an R. This R is very, very important, okay? So the R, and it's a lowercase r, is the correlation coefficient. Okay? And the closer this correlation coefficient is to 1, the closer to 1, the better the equation models the data. Okay, and it also says another thing. If the correlation is positive, it has a positive slope, or the equation has a positive slope. If the r is negative, it has a negative slope. Okay, so some of you, and let me scroll down, some of you, when you get to this screen right here, you'll have an R on it. Okay, some of you won't, and I'll show you if you don't. So some of you will have an R, as I believe this one does. Yeah, right here. This would be the correlation coefficient. Okay, if you're like me and you don't have an R, this is what you have to do. All right, so if you don't have R on here, you can find your R by going to VARs. Once again, down to stats. At the top, EQ, which stands for equation. And then you see your R right there. You don't want R squared, just R, enter. 0.995-ish. Okay, so I'm going to write here. R is roughly 0.995, okay, which is a positive slope, but it's also a very positive correlation coefficient, meaning that the scatter plot and the line of best fit match each other very well. Okay, so if you want to graph the line along with the scatter plots, right, if you want to plot the line with scatter plots, you'd go to y equals like you normally do. Then you'll go to VARs, down to statistics, over to equation, and number 1, reg equation, enter, and it automatically puts this right here, this 2.66 whatever, into the calculator, okay? And then if you hit the graph, there you have it. So as you can see, this line does model that data pretty darn good, and there is a positive slope which goes with the correlation coefficient. All right, so now let's answer the question. So yes, it's linear. Write equation of line of fit and use it to estimate the height of a person whose femur is 35. All right, so if the femur is 35 centimeters long, we're just going to plug in 35 for x. So y equals 2.6 times 35 plus 64.99. And when we do that, we get roughly, I get 156.12. All right, now I want you to pause this here, and I want you to go through and try to do this one on your own. And you can go back and look at your notes if you need to. You'll get extra practice in your homework, so I'm not worried about you memorizing it at this point. But do that same process and then answer these 3 questions. So try to do it on your own. Pause this, try to do it on your own, and then we'll go over them. All right, so part A, we want to find the equation. Okay, so I've already entered in here. Stats, calculate, this is a linear regression. Calculate, here I am. Okay, so my equation is roughly y equals, you plug A in for A, 3.0527 plus 63.53. So I'm going to write that down. So f of x equals 3.05x plus 63.53. Okay, so on B, estimate the height of a female whose humerus is 40. So that would just be f of 40, 3.05 times 40, plus 63.53. And if we plug that into your calculator, that gives us roughly 185.64. Last thing we do is find and interpret the correlation coefficient. So if you're lucky and your small r is here, take it and run with it. If not, remember we go to VARs, down to statistics, because that's where we're storing everything, over to equation, and then down to our lowercase r. Not r squared, just r. And it's roughly 0.985. Okay, it's positive, so that tells us there's a positive slope. And it's very close to 1, which tells us it is a very good line of fit.